thank you everyone for attending this webinar. My name is Vikram, and I'm joined on this webinar by two of my colleagues, Alan Revzin and Sunil. Let's go ahead and get started. The topic of today's webinar is SONET SDH testing solutions. Just a really quick overview of GL Communications in case you're not familiar with us. We are headquartered in the United States in Gaithersburg, Maryland. We've been around for over 30 years. We have two divisions to our company. We have a consulting division and a products and solutions division. The subject of today's webinar is on our product and solutions division, where we make test and measurement equipment. We produce test and measurement equipment for basically all telecommunications networks. So whether it's the public switch telephone network, an Ethernet IP network, any sort of wireless or cellular network, or SONET SDH network, we provide test equipment to analyze and emulate and visualize and capture and store the data on these networks. So that's a little bit about our company. The consulting side does basically all sorts of telecommunications consulting and more generally engineering services consulting as well. We've been around for over 30 years, and please definitely contact us for any sort of telecommunications challenges or consulting needs or products or solutions. So today we are going to focus specifically on SONET and SDH networks. So the agenda for today is to talk about SONET and SDH briefly, and then we'll talk about the various testing scenarios that you may be interested in for SONET and SDH networks. And that will kind of set the stage for us to talk about our SonetExpert. SonetExpert is a new product that we've launched just recently, and we're going to specifically focus on channelized applications. And then after discussing SonetExpert, we'll have enough time at the end for question and answers, and we will stay on for as long as necessary to take as many of your questions and hopefully answer them as completely as we can. So that is the agenda. So let's go ahead and dive right in. So first off, I think most of you are already familiar, but SONET stands for Synchronous Optical Networking, and it is used in North America. And SDH stands for Synchronous Digital Hierarchy, and it's used in the rest of the world. SONET and SDH are both optical transmission protocols for high-speed voice, video, and data. And the data rates, usually when you talk about SONET, you talk about OC, optical carrier, followed by some integer. So like OC3, OC-12, OC-48, and so on. For SDH, usually you talk in terms of synchronous transport module, STM, followed by an integer. So STM-1, STM-4, and so on. Both SONET and SDH can carry channelized and unchannelized data. The channelized data is in the form of T1 E1s. So for instance, on an OC3 or STM-1 network, these can support 84 T1s or 63 E1s. And on an OC-12 STM-4 network, it can support 336 T1s or 252 E1s. Now, like I mentioned, SONET and SDH also carry unchannelized traffic, such as packet over SONET or asynchronous transfer mode and other types of protocols. Today, the focus is going to be on channelized applications. However, if you do have questions about unchannelized, we can address that as well. We also have other solutions for unchannelized applications, but today we'll focus mainly on channelized applications. Okay, so SONET and SDH networks are fast. They are optical networks and they scale very nicely. So, you can start from OC1, OC3, OC9, going all the way up to OC3072. and it scales very nicely so that the line rates get to be very, very fast. So for instance, OC-3072 is 160 gigabits per second. So these optical networks are extremely fast. They're used in the backbone a lot, and basically they scale very nicely. You can group multiple OC3s into an OC-12 and so on. So yeah, so this is just a table to tell you that these networks are very, very fast and ideal for like backbone transport. Okay, so how is it all grouped together? How is all the traffic aggregated? So here what we have on the right-hand side is kind of a breakout of what exactly is in an OC-12 or an STM-4 pipe. So the OC-12, for instance, is at 622 megabits per second, and it is comprised of these 4 red pipes, which are STM-1s or OC-3s. And each individual STM-1 or OC-3 has groups of T1 and E1s, so that overall you have 84 T1s or 63 E1s in an STM-1 OC-3 pipe. So if you want to further break it down and start from the very top, from the very fundamental unit, you basically have these DS zeros, digital signal zeros, and they are 64 kilobits per second, and they can carry digital traffic or voice traffic. And basically T1 and E1 carry multiple DS zeros. So T1 has 24 DS zeros, and E1 has 32 DS zeros. And the STM-1, like I mentioned, it has 84 T1s or 63 E1s, and the STM-4 is 4 STM-1s, so that an STM-4 carries hundreds of T1s and E1s. So if you just do the math, you'll see that like an STM-4 or an OC-12 network can carry basically 8,000 data streams, roughly 8,000 of these DS zeros. So that could be potentially 8,000 voice calls traversing an STM-4 or an OC-12 network. So for those of you who are familiar with GL communications, a lot of our focus is on analyzing voice calls, and we'll talk about that more later on in the presentation. This slide just basically describes how these SONET networks are deployed in the field. Basically, they're deployed in these ring type topologies where you have these add-drop multiplexers, and each customer site is hanging off one of these add-drop multiplexers. And multiple rings can be chained together through a central office, and these rings can form a backbone network basically. So this is kind of just how, just a very simplistic model for how these SONET networks, what they tend to look like. Okay, so here I think is what a lot of our viewers today will be interested in. What are the different types of testing scenarios on these SONET and SDH networks? So you can break down these testing scenarios into 2 different categories really: monitoring and emulation. So first off, a lot of customers want to be able to monitor these individual T1s, E1s, and even DS zeros directly without requiring physical access. So if you're tapping into an STM-1 network, we get a lot of customers that want to be able to access the individual T1s and E1s on these networks. And they usually want to be able to readily identify different traffic types and protocols within these complex SONET SDH structures. The SONET SDH networks are, they're multiple, they're these big pipes with little pipes inside of them. And so sometimes it's very difficult to kind of analyze what type of traffic is actually traversing this network. Is it voice traffic? Is it something else? And a lot of customers are interested in capturing and analyzing voice calls for call quality or surveillance. So that's a big thing, right? Being able to capture and analyze these voice calls. So later on, we're going to show you some screenshots on how our cutting edge products can do that. May be interested in load testing a SONET SDH network by generating the maximum number of voice calls or data streams. So you may be interested in seeing how does your SONET SDH network handle all of this traffic. So you may want to artificially load up these SONET SDH networks. And so load testing is also another requirement we hear customers talking about. And finally, because these are such huge networks carrying so much traffic, a lot of customers want some sort of real-time alarm detection and management system. So usually customers like SNMP for network management. And so they want to be able to send some sort of SNMP trap at that individual T1 E1 level for network management purposes. So they want to be able to inspect those individual T1 E1s, and when they see something anomalous or something that they want to be alerted on, they want to be able to quickly send an SNMP trap so that they can see, so that they can be alerted, basically. And we can talk about that later on. So I hope that I kind of went fast there, but I hope that has basically set the stage for GL Communications testing solution, our channelized testing solution called SonetExpert. So on the following slides, we're going to talk in detail about SonetExpert and basically how it can address each of these testing scenarios that I mentioned here on the previous slide. So, so what is SonetExpert? SonetExpert is a very portable hardware platform. We're actually not showing it to scale here. It looks smaller than this when you compare it to a laptop. But basically, this hardware device is configured from a PC via a USB 3.0 connection. So it's very fast connection. And the SonetExpert has 2 ports on it that are meant for channelized applications. So OC3 STM-1 and OC-12 STM-4. So these 2 ports are meant for those channelized applications. And so you would basically, using SFPs, just hook up directly to that fiber network, maybe through a tap, and you can do all of your analysis through the computer. Actually, the computer configures the SonetExpert, and also you see all of the test results on the computer in a nice, comfortable graphical user interface. So it's, so like I say here, it's configured from a Windows 10 PC, and it's very small, it's very portable, so you can just take this with you, take a laptop with you, go out into the field. It's very easy for field testing. Now, some of you are familiar with our PacketExpert product. We have PacketExpert 10GX, and so when you look at this SonetExpert, here's the front panel and here's the back panel, you may be thinking, oh, this looks just like our PacketExpert. And you are right. This is actually the same hardware as our PacketExpert. So what we've done is we've basically combined the Ethernet testing capabilities of PacketExpert and the OC3 STM capabilities using the port 3 and 4 to create this SonetExpert platform. So the focus of today is going to be on these 2 ports, because these are the ports that do your optical testing for OC3, OC-12, STM-1, STM-4. But we also do have these Ethernet ports. So if you basically need to inspect some sort of diverse network where you have Ethernet links as well as these SONET SDH links, you can actually do it both using this this SonetExpert platform. The back, just basically you plug in a power supply, and here's the USB 3.0 connection to the PC, and we of course supply the cable. So so like I said, we're going to focus on these 2 ports. And now I'm going to hand it over to my colleague Sunil, who will talk more in depth about what SonetExpert can do for you. Sunil, would you like to narrate this slide?
Yes, Vikram, thank you. So some of the important SonetExpert features, as Vikram said, we have two channelized ports that can be used for OC3 or OC-12 interfaces, and each port can be configured to simulate any particular protocol or monitor the calls, incoming calls in both the directions. And we have flexibility of configuring any required T1 or E1 channels that can be multiplexed or demultiplexed into a normal STM line. So out of 84, user can configure any required number of E1 or T1 channels. And using these T1 and E1 channels, we can like analyze the calls or simulate some voice call like data, fax, or different protocols, or it can be like analog or digital signals. That also includes like echo and voice quality testing. So some of our important applications are like protocol analysis and emulations. So if you are familiar with our T1 E1 products, we do support all the special applications in SonetExpert such as HDLC, SS7, ISDN, CAS, point-to-point protocol, frame relay, ATM, as well as like GSM, A interface and ABS interface, both emulation as well as analysis of all the protocols. So we have flexibility of recording a call at the wide speed level. As you know, STM means it has, or STM-1 has 155 Mbps and STM-4 has 622 Mbps. Even with that speed, we are able to capture as well as we can transmit at that particular speed without any interruptions. Suppose if you want to simulate, means if you want to duplicate the same data on the all other remaining T1 and E1 channels, we have simple options that can broadcast selected any T1 or E1 channels on the all 252 E1s or 336 T1s. That is a simple option configuration. User can like enable the broadcast or disable the broadcast. So once they have enabled, whatever the data we are transmitting on particular one T1 or E1 channel, same data will be replicated on all other 252 E1s or 336 T1s. So user will also get direct access to any T1 or E1 channels even at DS0 levels. Here one example, that is 336 T1s or 252 E1s. That is per channelized ports. We have two such channelized ports. So total we will get around 16,128 DS0 for T1 and 15,624 DS0 for the E1. So we have simple pluggable SCPs that can be used for the fiber optic non-intrusive tapping, so that we can simply tap incoming STM lines, or as well as we can simulate the by using simple pluggable SCPs that can be a single mode or multi-mode. Like I said, we support any combinations of DS0 that can be a 64 kbps channel, 56 kbps channel, or even at the sub channel level like 8 kbps channel. So both fractional T1 E1 or entire hyper channel N into T1 E1 hyper channel interface. So that is for total of 252 E1s or 336 T1 per port. So we have simple like suppose if the STM line has any issue, we have hardware alarms like loss of signals and loss of frames, as well as we have service logging option that will log when the STM service has been started and when the service has been stopped, as well as suppose if the STM line has any issues or if you observed any errors, so all the information will be logged. and we do support external clock support. Our hardware itself, it has internal clock, as well as user can provide their own external clock. We have line and diagnostic loopback options. Like line loopback, suppose I want to retransmit the data. Suppose I am receiving some STM-1 lines and I want to retransmit it back. During that time, I can simply select line loopback option. So you, user will easily retransmit all the received all the STM data. So we also have like diagnostic loopback. Suppose I am transmitting some information and I want to I want to store that data. During that time, I can use diagnostic loopback option, so that whatever the data I am transmitting, I will be receiving it back on the same port. We have like cross port options like through mode and port swap options, like receiving on the one channelized port and transmitting it on the other channelized port. Or else, suppose if I want to transmit something on the port number 3, instead of transmitting on port 1, I can simply swap that transmission port, and instead of port number 3, I can transmit on port number 4. So we have such options. And we support multiplexing of different T1 or E1 channels into a normal single channelized STM-1 or STM-4 line. So both multiplexing as well as demultiplexing is supported, and user can configure like required mapping. We do support VC3 mapping and as well as VC4 mapping, both for T1 as well as E1.
Okay, thank you, Sunil. So
Yeah.
I just want to emphasize how convenient this SonetExpert solution is. So let's say that you want to tap into a fiber optic network, and traditionally, in the past, many years ago, GL would basically provide a solution where you would plug in your fiber tap into this optical network, and then you would feed it to a STM-1 multiplexer, and this would demultiplex the traffic into individual T1s and E1s. So that's potentially, if you're tapping into like a OC3 STM-1 line, that's potentially 84 T1s or 63 E1s. And so then you would need a lot of different cables to go from the multiplexer into our octal cards. So we used to sell these octal cards, we still do, and each octal card has 8 T1 E1 ports. So potentially you would have to buy 8 different octal cards just to monitor all of the 63 E1s. And so if you can imagine, this solution gets pretty cumbersome pretty quickly, because you have to have all these cables for all these individual E1 and T1s, and then you have to have 8 of these octal cards. And we have to stick and the octal cards get stuck into server grade PCs. And so basically what you end up is a whole rack of the multiplexer, the rack PCs with the octal cards, and all of this different cabling just so that you can inspect the individual T1s and E1s. It's a very cumbersome solution, and it takes up a lot of space. It's expensive, a lot of cabling, and it's very confusing too. It's not easy to configure all of this. So now with SonetExpert, it's much more convenient. All we do is plug in our SonetExpert to this fiber tap, and then you get full visibility into all of the T1s, the hundreds of T1 E1s, and the thousands of DS0s straight from your computer. You can see the individual DS0s straight from your computer using just one hardware box plugged into a fiber tap. So this is much simpler, it's much cheaper, and it's just much more user-friendly. And you can do a lot more with SonetExpert than you can with this huge rack of octal cards and multiplexer. So On this next slide, I'm going to hand it over to my colleague, Alan, who will walk you through what it all looks like.
Our SonetExpert Channelized is culmination of more than 30 years of refinement of T1 E1 testing equipment. Our first hardware-based T1 E1 analyzer was handling just one port. Now we can handle hundreds of ports, and our T1s nowadays have probably the richest in the industry functionality, number of optional applications for different kind of analysis and testing. This slide shows the view of what we call soft T1. It has two major panes at the bottom, which shows physical layer alarms and error counters. There are hundreds of ports, so the first column shows summary. If anywhere any port has problems, all ports will show either current status, which is okay, or historic status if it was an error encountered, or X, red X, which will show error on the screen. And the lowest pane shows error counters for different kind of error conditions on T1 E1 lines. So next slide. This is probably the most useful application for surveillance and for protocol testing analysis. It shows our protocol analyzers, and if we want to, we can capture all T1 E1 ports, and we can see signaling messages, as well as at the bottom pane of the protocol analysis, we can see call detail records for each call placed on any of T1 E1 channels. And the right part shows that we can select different kind of signaling, even if, let's say, telecom operator is using different kind of grooming. It can be single channel or time slot on T1 or E1. It can be groomed. Some T1s carry multiple signaling, or it can be more than 64-bit per channel signaling. We can handle all this stuff. In addition of standalone analyzer, we can also use it for surveillance system when multiple SonetExpert at different geographical location collects this data, and we can ship it to centralized database to collect all this T1 E1 call information. Even so, separate T1s can carry different kind of traffic, ISDN, SS7, GSM. We will collect in database for subsequent analysis. We can also capture voice calls, analyze quality voice calls using these protocol analyzers. They are very similar to our hardware-based T1 E1. Practically all the functionality you can use in SonetExpert. Next.
Yeah. We have protocol data analysis, which is part of our normal protocol analyzers. So here you are seeing ISDN protocol data analysis. It will give detailed information about each and every call detailed records. So all the calls will be arranged in a row based. So user can select any required CDR information that will give more information about when the call has been started, what is the setup duration, and how much time it has taken for receiving the call, as well as billing duration and total durations. So all the information user will get. So selecting on any particular call will give call flow of that particular call. So here we are getting ISDN call flow, and on the left side we will get timestamp about that is the duration of the particular call. So clicking on again individual message flow, we will also get decoding information of that each and every messages. So PDA is a new application though that can be used for recording a call as well as exporting all these information to our centralized monitoring application, that is net server web. So all the information can be exported to a Oracle database. So for that, PDA is the useful application. So user can record a call as well as export the information to database, as well as they have flexibility of viewing complete call flow along with decoding information of each and every call. We also have some filtering options, like here it's showing show all calls. That includes both passed calls, failed calls, as well as active calls. So user can simply select a drop down option for only for displaying only active calls, or like completed calls or any failed calls. So we have more features of PDA, like triggering and action. Like suppose if the user is interested only in particular number, like depending on calling number or call number, user can filter out all those calls and save those calls, so that later on they can do offline analysis of call of interested calls. Okay, next.
Yeah, I just want to add to Sunil's points there. You can basically click on any one of these calls, and we don't have it highlighted here, but you can play back the call just by hitting this arrow, and you can stop the call. So you can actually listen in on the calls. And then, as Sunil mentioned, if you're trying to, maybe, I don't know, maybe if you want to do some surveillance or something and you want to set up an alert for whenever a specific caller number is received, then you can set up an alert, and you can just click on this alert summary, and you can see every single time when that specific caller made a call. And you don't just have to do it based on the calling and called numbers. You can do it on things like the call quality. We can tell you like the mean opinion score, so you can get the voice quality, and you can set up an alert on that. So that way, like if you want to troubleshoot, like when you have poor voice quality on your network and you all of a sudden have a bunch of calls with poor voice quality, that you can set up a little alert that can that you can then click on it and see which calls had poor call quality. I just want to add that. Thank you, Sunil. Let's go to the next slide.
Yeah, like I said, our device supports both emulation as well as analysis. As you all know, STM means it can carry any informations. So we can replicate those scenarios, like by simulating such any protocols. So one example, SS7 call, simulating SS7 call. So they don't have to do in a real network. We can replicate such scenarios using our maps applications, and we can simulate different protocols like SS7, ISDN, and GSM A interface or ABC interface. So as well as we can also tap those line and capture using our device. Like, so both emulation as well as monitoring is possible. So next we will show how we can simulate such real-time scenarios, like by generating some calls. Here we have like two different applications running. One is iZoop simulation, as well as one is call generation window and call reception window, and finally report windows. So we can simulate here in this example, we are at a time we are simulating 1890 calls. As you can see here, we have active calls, simultaneous calls, and number of calls per seconds. So how much calls has been completed, and how many calls are passed, as well as what is the actual active calls. So all the information we will get in a graphical view. So in call generation window, as you can see here, we have different profiles like all the 63 E1s and each at time slot level. So we are simulating 1890 calls. This is just one example how we can replicate real-time scenario by simulating any protocol calls. In this example, it is we are simulating iZoop calls.
Yeah, so this is what we were mentioning earlier about load testing a SONET SDH network. So you can generate thousands of calls simultaneously on these networks to load test the network. This is a nice way to highlight how that all works. Alan, so do you want to talk about the working principle of SonetExpert?
Sure. This picture shows our architecture. Basic components are hardware on the left and two major pieces of essential software. It's channelized service on the right, which basically controls the card and transmits and receives data from SONET and SDH networks. And at the bottom is what we call soft T1 E1 analyzers. We already showed picture which has this variety of T1 E1 application. There is one optional part which is not shown on this picture is SonetExpert control utility. We can see on the next screen. Let's go to the next. This is basically optional view or microscope. We can open it at any time, close at any time. It shows the status and configuration of the SonetExpert service, which is running on background. On the left, it shows how SONET SDH is configured, what channels are used, what mappings are used. Top row middle picture shows status, physical status of SONET lines, and right picture shows hardware essential counters for SONET hardware, and bottom part shows max demax status and essential counters for T1 E1 channels within this architecture. Once again, this application can be used to start and stop service at any time, and it does not need to be running all the time. It can be opened and closed whenever necessary, freeing real estate of the screen. Next slide. And this is configuration of T1 E1 channels within SONET or SDH. We can configure any numbers of T1 E1 channels as showed here. We can configure clock, cross-port, and loopback status. This option actually makes cabling connection, tapping to the network much easier, increase really flexibility how our users will use our product. Next.
Yeah, these are all some of the examples we are supporting, like SFEs. Like it can be 850 nanometer, 1310 or 1550 nanometer SFEs we support. We support normal LC optical fiber connectors for our channelized operations. So finally, like I said, we support VC3 and VC4 mapping for T1 and E1. This is example of SONET mapping which we support, and the highlighted all the highlighted in green color which is supported by our SonetExpert device. In this example, like we are showing OC3, that can be a 3 different STS1 group and followed by these 7 virtual tributary groups followed by like virtual tributary 2 unit 3, that will gives us 63 events, or else it can be like 4 VT 1.5, so that will gives us 84 T1 for one OC3 line. So such we have four STM OC3 lines. So maximum we do support 84 cross 4, that is 336 T1 channels per port. If you use both our channelized port, those port number can be up to 672 events. T1s we can monitor. So we do support both SONET mapping as well as SDH mapping. Here we are showing only SONET mapping.
Okay, great. Thank you, Sunil, and thank you, Alan. This presentation will be made available on our website, and you will receive an automated email when we post the webinar. And please, for more information on SonetExpert or any of our telecommunications testing solutions, please contact us at info@gl.com, or you can go to our website, gl.com, and fill out our information request form. And in case you're not subscribed already to our newsletter, please subscribe to our newsletter, where we often advertise upcoming webinars and other news and other product releases. And thank you to everyone who attended this webinar. We hope you found it informative, and please feel free to contact us for any other questions that you may have. Thank you, everyone, and we'll end the webinar now. Please be safe and have a good rest of your day.